Okay, I'm assuming you've read over number 8. You looked at the diagram.
It's 4.
Do we have anything parallel?
No.
No?
Yep.
Yes, we do.
Because hopefully you read something.
Yep.
So these guys are parallel. And they want us to find DE, so I'll put an X there. So can we use just the segments, or do we need to use full sides of the triangle here?
Full size.
Right? Because the X is on a full side of the triangle. Okay? So what did we get for an answer?
3.
How many got choice 3? 25. Okay, well, if you didn't get that, somebody give me a proportion. Well, by the way, this is going to be 24, right? So what's the proportion? Okay, I'll buy that. I'll leave with the X. They correspond, right? So you got 24x equals 40 times 4 times 15, 600, right? So x equals 25. Okay. Let's move along. Number 9. Read it. And they give us a little something different in this one. So think about it for a minute. I'll go ahead and put the measurements in there. dB is 6.3. And AC is 9.4. Length of DE, put an X here. We have parallel lines. So what's the twist in this one, guy? What's different here? Right. But they give us something that's a little different than the other ones.
AD to DB.
They give you a ratio, right? Kind of, isn't that kind of, it's a scale factor too, isn't it? Okay. Yeah, we could probably do something like that, but we need.
3.5. Like.
Where's 3.5 come from?
I mean, not 3.5. 3/5 in like the proportion.
That could definitely be used,
Okay.
right? But let me ask you this. Let's think of this 3 to 5. So it's 8. So it's AD. So this would be 3, and that would be 5. So this would be like our 3 to 5, right? And I'll put it in parentheses because we're not actually saying it's got a length of 3 and a length of 5, right?
Yeah.
Right. Remember, that's going to be like a lowest terms thing here. But what would be the scale factor, though? So it's not exactly scale factor because the 3 is not referring to a full side, right? So we got to connect some things here. So if something's in a ratio of 3 things to 5 things, how many things are there altogether?
I don't like the term
8 things. You know, like from what?
things. It's too much specific.
That term.
Well, the way I was asking it applies generally to anything.
Things.
So I'm trying to take you outside the problem with your brain and then bring your outer knowledge into it. You make, okay? That's what I'm doing there. But, you know, things that you have. Is there some PC term now that we use to start things? Yeah.
No, I thought you were doing it so one of us would notice that you're just saying things.
Oh, okay.
Yeah, I don't
I'm taking
know.
for notes.
Should I notice?
Well, how do we handle that 3 and 5? So really, what this would be 5 to what? Aha. So our scale factor, everybody say it's 5 to 8, small 8. Whoops, make that an 8. 5 to 8, small to big. Does that make sense? Okay. Does anybody not understand why it's 5 to 8? So if 3, or the 5, that's the side of the small triangle. But to get the scale factor, we need the corresponding ratio for the big side, and that's 5 and 3 is 8. The whole thing is 8. Okay? Now we can use scale factor like we always have, can't we?
Yep.
Scale factor now, if we think we connect our similar triangles and dilations, right? Scale factor applies to any linear measurements. Is X a linear measurement? And at 9.4? Okay, so set up a proportion, see if you can solve that then. So what do we got here? Anybody? How many got 5.9? What was the equation you set up? Okay. Yep, small over big. You're doing small over big, aren't you? Equals small x over 9.4, right? So we got 8x equals, what does that end up being, 47? Equals approximate because you're rounding, right? You guys know what that squiggly equal sign means, right?
Nope.
It means approximately equals. In other words, you've rounded somewhere, okay? All right, let's go to number 10.
Okay, got the answer.
Diagram, so we got these are parallel. All that stuff, that's 5. What is the length of QR? Well, we'll call our QR X. And whatever, I always like, I mean, you can do it differently. I always like whatever they want you to find, just put it next there. There's other ways to do that. But. So we said X over 5, right, equals 5 over 2. So what you're telling me is that this side that we called X corresponds with that 5. Right? You see what I mean? Something. We need something that'll correspond with the 5, don't we? What will correspond with the 5? 7? Well, something on this side. What on this side? So wouldn't it be that X? Well, yeah, right? If the whole thing is that, we need this, right, to correspond with the 5. The whole thing is X, and this little part of it is 5. What's left for this part? X minus 5. Now you can set up your proportion. Okay?
So you still set it up the same way?
Yeah, now you just set up, now you can set up correctly corresponding things to corresponding things, right? And by the way, so X is going to correspond with what then? What is X? Yeah, right? So X is a full side, okay? So what would be our proportion? Let's see. Let's over what? Over 2. There's a couple ways you could do it, right? I could do X minus 5 over X equals 5 over 7. What else could I do? Could I do X minus 5 over 5 equals X over 7? Right? Remember that there's all sorts of corresponding things you can set up here. The way I was looking, I was doing X minus 5 over 5 equals X over 7, right? So whichever way you did it, maybe you did it differently than this. Go ahead, cross multiply and solve it. See if we get the same answer.
Yeah, I did it weird. Like
Well, what do you mean by weird? What did you do?
because I put X minus 5 and then under the X minus 5 I put X, which is weird.
X minus. So you did small to big. That's not weird. And then what equals what over what?
What? Oh, I put 7 over 5.
Oh, well, hold on now. You did small over big, and then you equals big over small.
Yeah, I don't know. I got the same answer.
Then you made a mistake that fixed your mistake by some cosmic coinky dink.
Yeah.
Okay. Well, let's just cross multiply the one I have. So 7 times X minus 5, 5X, right? 7X minus 35 equals 5X. Let's subtract 5X from both sides and add 35 to both sides at the same time. You can handle that now, right? We don't have to show all those little baby steps anymore. So that give us 2X equals positive 35.
Yeah, but then we get the same answer that we got before, that I got before.
I got
Just did it different.
The same answer, just different.
I know, it's because some people decide to tell you the whole angle, not just the
Side you can.
We still use that exception.
All right, so tell me what you set up there. Just maybe clear on what you set up, maybe the, one of the alternate ways. Go ahead, say it. 2 over, quiet guys, 7 equals what?
5 over X.
Okay, that's, yeah, right? And why can you do that? Why can you do that? Because the lines are parallel. Remember that? Because these are, we know they're parallel, we have that option now too. That goes to the side splitter. The way we were setting it up was just when we had our similar triangles, right? Not necessarily knowing the sides are parallel, but then the side splitter will allow you guys to do that. Say that one more time. You did what over what? 2 over 7. Let me just do this. Or 2 over 7. Go, Mr. Alo. And then you had what over what?
5 over X.
Yeah, do you see that? So that little segment over the whole thing corresponds to that one, right? Equals 5 over X. Well, that simplifies it too, right? So a new side splitter. Did we scare you away, Mr. Alo?
No.
You seem a little frightened.
He's busy with the popcorn.
He's busy. So look, then you get your, right here, you get your 2x equals 35. Right? Because we knew they're parallel, yeah, that's a valid option. We couldn't really use that before with just a similar things. Okay?
But now that we have to parallel.
Yeah, that, so it opens up, you know, different ways to approach it. Remember the first part of that section, they had the parallel lines and they had, it was like 30 different proportions you could set up, right?
Oh, I
Okay.
know why I got the answer right, is because I wrote down a different equation that was wrong, and I didn't erase it.
Well, that makes sense. Okay, I think this is the last one. No, we got 2 more. 2 more. All right.
I'm so sorry about me.
Read this one over, get your stuff. You know what? Wait, this is just like, no, we did this one like twice already somewhere else.
Oh,
With the trapezoid perimeter, you got 20s all over the place, remember?
Everybody's.
All right, let's go down to number 12 and put a bow on this.
I know that is.
And also we can say, this is the 6-foot wooden stake. We can assume that that is perpendicular to the ground. All right? Let's put some measurements in here. So that's a 6-foot wooden stake. That's 6, right? And you place it at 50. Oh, no, that's not this. Yeah, that's just, what's this thing there? That's just 3. All right. So this distance here, 15. You can do that. Some of you don't like making your little brackety things. You could do that too. Okay. So who thinks they can explain why these triangles are similar? Yeah, we'll go ahead. Well, did you read the problem? It says it's anchored to a stake in the ground 15 feet from the base of the pole. This is the pole.
Oh.
15 feet away is that stake. Okay. Any thoughts on how to answer why these triangles are similar? Do we have some ways to prove triangles similar up here? Right?
They share the,
They share a what now? Be careful. They share a what?
they share
Oh, okay. They share this angle. Is that so? That's reflexive property, congruent. Yeah. What else? And what do you know about right angles? That's not enough. It's still not enough. What do you know about all right angles? They're congruent.
it's like all equal.
You said that?
Yeah, it's
You can say it louder.
say it louder.
Yeah, you can say it.
Oh, here I am. Make sure you're.
Can't read your lips when you're in the master. Oh, so what do you think now? Are they similar by angle? So how might we explain this? We can say both poles are perpendicular to the ground, right? So what does that form? Both poles are perpendicular to ground. Forming what? Well, let's tie that up a little better. There we go. Let's say that. Let's get that in there. Congruent right angles, right? And, what did you say, Lily, before? And they share the angle, right, with the angle with the ground. And they share the angle with the ground. So how do we sum this up? So they are what? By what? So they're similar by angle. So the triangles are similar by angle. Okay? So all this stuff as we learn it, you know, it's not different stuff, right? It's just approaching really kind of the same thing from a different angle, right? I hope you're kind of catching that.
Angles.
Yeah, sure. All right.